Need to analyze text content with AI tools, but don't want to deal with complex parameter handling? We'll create a FastMCP tool that processes text with configurable options, showing how to handle optional parameters, type annotations, and default values in a way that's both AI-friendly and developer-friendly. The pattern demonstrates how to build flexible tools that work seamlessly with language models while maintaining clean Python interfaces.
At MCP, tool. Def analyze text. Text, SDR. Max tokens, int equals 100. Language, SDR none equals none. Dict. Analyze the provided text. Hash implementation.
This demonstrates the tool abstraction pattern for AI integration, where Python functions become first-class capabilities that language models can invoke programmatically. The Decorator approach transforms ordinary functions into self-describing tools with automatic schema generation, parameter validation, and type-safe execution. What makes this distinctive is its dual nature. Functions remain normal Python code while simultaneously being exposed as structured, AI-callable operations. The pattern works by leveraging Python's type system and Decorator metadata to create a bridge between human-readable code and machine-readable tool definitions. FastMCP inspects the function signature, extracts type annotations and docstrings, then generates an MCP-compatible schema that describes the tool's capabilities, constraints, and expected outputs. This declarative approach maintains separation of concerns. Your implementation focuses on business logic, while the framework handles serialization, validation, and transport. This approach solves the core challenge of AI system integration, safely exposing backend functionality without compromising security or maintainability. By using native Python constructs, you avoid writing separate API layers, validation code, or documentation. The function signature itself becomes the contract. The trade-off is some initial type annotation discipline, but the result is tools that are simultaneously developer-friendly and AI-accessible, with built-in validation and discovery. Let's break it down line by line.
At MCP, tool. Def analyze text.
The @MCP tool decorator marks this function as an AI-callable tool. It automatically generates an open API-compatible schema from the type hints and docstring, enabling the function to be discovered and invoked by AI models through the FastMCP framework.
Text, SDR.
This type annotation enforces that the text parameter must be a string, preventing runtime type errors. FastMCP uses these annotations to generate the tool's schema and validate inputs before execution.
Max tokens, int equals 100.
This sets a default token limit of 100 for text processing, controls input size to prevent excessive computation while allowing override when needed.
Language, SDR none equals none.
This parameter makes language selection optional. The SDR none type hint combined with none default means callers can omit the language, letting the function auto-detect it or use a default, while still accepting explicit language codes when needed.
Dict.
This return type annotation enforces structured output, requiring the function to return a dictionary. It standardizes the response format for AI tools, ensuring predictable parsing by both models and client applications.
Analyze the provided text.
This docstring defines the tool's purpose for AI models and human developers. FastMCP uses it to generate the tool's schema and documentation, while also serving as the function's standard Python documentation.
Hash implementation.
This placeholder marks where the actual text analysis implementation would go. The function signature already defines the contract. It takes text, optional max tokens, and language, then returns a structured dict with analysis results. Type annotation pattern. FastMCP's type system bridges Python's static hints with dynamic AI interactions, where SDR none becomes a client-visible contract rather than just documentation. Optional parameters default to none in the schema, but clients may omit them entirely designed for both cases. This pattern enables tools to evolve without breaking existing clients.
The schema that describes nothing describes everything.